So good morning everybody. So today in this particular 10th day, what we have planned is we are only going to take a recap, and I will be telling you about our department and the opportunities which you can get in our department, and we will be taking your feedback in the online mode. The link has been already shared in the group. So before starting, so I will just recap that how we have actually planned this sessions, as whenever we are talking about any new technologies. So new technology does not always means that you can, or it will be novel throughout. It will be changing its things. As say if I am telling about the traditional drying and methods, and then nowadays what drying methods are used. Say for traditional methods we are using the sun drying we were using. Why there was actually a need to go from a sun drying to another drying? Say for example mechanical dryings and everything, then we have gone for another non-thermal dryings and everything. What is the need actually that arised, because of which we have just upgraded ourselves? There is a science behind that. What? Once we were very happy with the traditional methods of dryings and everything, it was drying only. But what was the problem? Once we got to know that, okay, there can be chances that we have to feed more people, then what we will do, we cannot store our things for the longer duration of time. Then came that, okay, it has to be rapid, because what was the problem in the traditional drying? That it is taking longer duration of time. Also, it is not, the predetermined level was not being achieved. Because of this particular problems, how it arises? Because of the experimental and the consumer behavior. So consumer behavior is always very, very, very important whenever we are talking about this particular things. So consumer asks that why it is taking 24 hours of time, why cannot we can just go for why we cannot go for 6 hours? So it has to be developed. So who developed that thing? Engineers. By applying the same science, that what we have done, that we have to remove the moisture content to the predetermined level. So what they have done, they have just simply removed the moisture content by using, say, hot air. Okay, hot air was the first principle which came into existence. Then after that, many methods came. Now, because of these things only, that traditional methods, and we thought that, okay, when we are going for these traditional methods and we are applying the thermal technologies, what is happening, that there is more chances of this, all the vitamins, minerals, or the sensory attributes, or any the volatile compounds which are there, that are more useful things, that are getting lost in the thermal thing. So what we thought, we have to go, because say tea we are taking the example, or spices we are taking the example. These things, what will happen if tea or spices will be there? What is the main characteristics of tea or spices? The aroma or the volatile compounds which are there. But that is not been preserved in traditional or in, say, thermal. So what we thought, why not to go for non-thermal drying? Now there is a concept called as non-thermal drying, in which what we are doing, there are two possibilities are there. One is called as electro-hydrodynamic drying. Nowadays this principle is coming into existence, electro-hydrodynamic drying. Also nowadays the plasma air drying or plasma fluidized drying is also coming. So these all things comes with the basic science and applying the higher things as per the consumer demand. In the same domain, we started that why not to go for blue circular economy. So first word which we picked up is the sustainable. So sustainable means what? Many a times whenever, you will be hearing this for 10 days, but the sustainability means what? Sustainability means that it is not that you will be creating the, say for example, any energy. What is there? You don't have to utilize all your energy, so that there will not be anything remaining for your future generation. In that domain only, how you are sensibly going to utilize the energy in such a manner that it will be again available for the coming generations. That is called as the sustainable. Because say for example, we are having nowadays bottles we are using, we are polluting our ponds, we are polluting our water levels, we are polluting say for example land. What is the problem? These things are created by us, because once nowadays we are hearing many things like EV vehicle came, EV bike came, EV everything came. But where is the disposal for that EV batteries? That is the problem or not? Now you will see in the foreign countries or anywhere, if you will be reading the Reader Digest and everything about the science and everything, in that you will be hearing these things, that disposal of these things are more tedious than that of the creation of these particular things. So that is why sustainability means do not just get over or do not just utilize everything, but keep something for your younger generation also. With that approach only, the sustainability came into this particular topic. Now this blue circular bioeconomy, it has been very well taught to you by Brijesh Tiwari sir. Feed and food value chain also you guys understood. I am here to just talk about this innovative approaches. I am from Department of Food Process Engineering, NIT Rourkela. So this innovative approach, as most of our faculties are engineers, what we deal with that how a process can be optimized in such a manner that it will be giving a less drudgery or less time or highest aroma, highest extraction. This is our aim as an engineer. What we are doing nowadays in our department, we are working on non-thermal technology. Non-thermal technology, example, plasma. Cold plasma is the technology which we are using extensively, and now what we are doing is we have utilized that cold plasma in protein structure change, starch modification of all the millets. So that work has been already done. Now, what was actually the problem which we were facing when there was no cold plasma? Because this cold plasma is not that it is meant for the food processing department. It is not meant for the food processing department. It came from this materials and everything, polymer. It was used in polymer sciences and everything. But we adopted that thing. What was the aim? That first we thought that why not to go for a technology which will not be giving any impact over the sensorial change attribute, or decontamination will be done without any effect on the sensorial attribute or any consumer preferences which is happening, all the sensory attribute and everything. So because of that, researchers searched about those things, and in that they came to know that the cold plasma is a technique which can be applied for the surface decontamination. Just know, for example, if you will just go and see that eggs, first when they started with the plasma egg, without coagulating, they decontaminated the whole shell of that particular egg. Now you will tell that, sir, egg is already having 6 layers, then why we are going for cold plasma? Because say for example, it is having 6 layers, it is not going inside the egg, but what is the problem? On the surface. If I am using, say for example, anybody is using the hand and they are just cracking the egg and they are putting and making into some dishes and everything, what will happen? The microflora which will be there on the outside, that only will be contaminating your food material. So that was the aim, that how we are going to reduce that thing. Later on, that we found that it is not having the penetration ability. Penetration ability is not there. So there came the delivery. First, we have ionized the air. After ionization, there is a delivery of the plasma to the food material. Now, when that delivery system we have designed, in that we found out that, okay, yes, if we are using, say, jet plasma, if we are using, say, example, dielectric barrier discharge, these kind of things, if we are using, it will be having certain penetration attribute on the powders, not on the solid materials and everything. It will be having the powder things. It will be, there will be impact will be there. With that, now what we have achieved, if I will tell you in our department, now we have this plasma air, we have this plasma activated water. Water is used everywhere. Now what we have done, reactive oxygen species and reactive nitrogen species, all these two things we have combined inside the water only. Now that water is only used for, say for example, decontamination, because every time what you are using for any surface decontamination, water you are using. So water also now has been plasma activated water is there, and that has been doing the thing by decontamination, because ROS, RNS is there. What will be there in any microorganism? There will be cell membrane will be there. That cell membrane will be made up of lipid, fat, protein only. It will be coming when the plasma ROS and RNS will be coming. What will be happening? There will be surface eking will be happening. Surface eking means it will be depleting because of this reaction of ROS and RNS with the biological cells. What will happen? There will be eking will be there. Means there will be some troughs will be created. Because of that troughs, what is happening? The ROS and RNS are going inside. There is no residue. It is going inside, doing the job. Protein changes, starch changes, all the properties of microorganisms changes, PEF same way. So in this manner only, Our department is now having 3 plasma systems. We have one continuous cold plasma system, we have a batch cold plasma system, and we have plasma activated water system. In these 3 systems, these are actually developed by our department only, and the plasma activated water which we are using nowadays has been extensively used for the modification of protein. Now, it was once we have thought of these things, we only thought that okay, it is going to work for the surface decontamination, but we are amazed to see that we have around 16 faculties, and there are somebody is working in, say for example, packaging, somebody is working in, say, superheated steams and everything. What they are doing nowadays, they are utilizing that cold plasma or plasma activated water, they are just providing it to their systems, and even packaging also they are doing, packaging film modification also they are doing with the cold plasma. So this is the, you can say, the innovative approach which is behind that, which I have thought of. Because whenever we are thinking, there is always no disruptive technologies are there, disruptive. This disruptive technology, from where it will come? Disruptive technologies. What is this disruptive technology? Novel disruptive technology. You might have heard the term this, no? From Brijesh sir. What is this disruptive technology?
Sir, introducing new methods, deviate from the conventional methods.
Okay, no.
Like
So how? What is the? Yeah, it is correct only. So disrupting means we have the science, we have the idea, we have the mechanism, all the protocols has been already set. But what we are going to do is, we are going to change all the parameters by exchanging the things, like conventional. Now we are going to do by our way. Our way means whatever way you want to do. So that is the innovative approaches which is happening in Department of Food Process Engineering and IIT Rourkela. Second thing which we are doing is, the major part is electro-hydrodynamic drying or electro-aerodynamic drying. Dryings which you were doing nowadays with, say, tray dryer or microwave infrared, combination of dryings and everything you were doing. Now we have just formulated a method in which we are going to dry our thing without actually heating it. By use of electricity, we are going to heat or dry our product. That is called as electro-hydrodynamic or aerodynamic thing. So in that, what we are going to do is, we are having water in the food material. Water, how it is going in the conventional method? Once it is getting heated up, that only is evaporated, that is the thing, it is coming to the predetermined level. Here what we are doing, we are providing or bombarding the electricity into the food material. Because of that excitation, what will happen? The water molecules which are there are certain forces are there. Because of that, once there will be cavitation will be there will be burst will be there of water. So what will happen? There will be eddies will be created. That eddies is now responsible for the dislocation of water from the food material. That is the thing now that has been happening, and it is very much applicable for all kind of food material, powdered also, and many of the food materials we are actually, spices and everything also we are doing, and it is very good in nutrient retention also, because we are not utilizing any heat. If we are not utilizing any heat, spices can be just stayed for a longer duration of time. So this is what is the innovative steps we are taking. These steps also came, like I will tell you the story of this particular technology. Last time we organized this GIAN course on novel disruptive technologies in food processing. In that only, there was shockwave. IIT Madras professor was there. In that IIT Madras professor, he was talking about the shockwave application in the food material. Now we thought, not in food material, something else. So we thought that why not we can also go for the same kind of thing, and we can approach the same approach in the food processing. From there we just know shockwave technology now we are utilizing in the food material. Why I am telling you these things? Because this innovative approaches which we are telling should not, if we are doing, it should also go with all the people. Because if you will be researching, if we will be researching, then only there will be outcome will be there, and that can be applied in any of the industries. Shockwave technology. Nowadays, no. If you will read one paper, there is no shockwave they are applying over the oranges, and that orange, without changing its any outer no membrane damage, nothing, and inside it is getting into pulp. that whole thing is getting converted into pulp. You can just put a straw and you can drink that thing. These are the technologies now coming into existence. That is there. So we are also doing the same shockwave technology here in our department. Then we recently have focused on this laser beam shockwave also. Laser beam shockwave. So these things are there, that once we are giving you a platform, that this is the innovative approaches are there, but these innovative approaches cannot be just meant and die here only. It has to be ever growing. Whenever you are seeing, there has to be a passion, that if you are reading a paper, you should not always reading a paper that is there from your domain only. You should be always exploring. Say for example, if I am a food engineer, I am continuously looking for papers of materials, material sciences or metallurgy or ceramics. I am looking for that thing. Why? Because there they have the technologies which has been applied in textile industry, which has been applied in polymer. So we also have the same systems. We also have protein, lipids, fats and everything we have. So why not that can be applied to this? Sometimes it will not be, but don't be a follower. Always try to make your own way. In that, what we have done recently is tomato preservation was the major problem in India nowadays. The fluctuation you might be also hearing in Uttar Pradesh, Bihar or down south also. There are problems are there, that no fluctuation, because once you will be, say suppose in the winter season, say suppose winter season we are talking about, because tomatoes are grown in say winter season. Now when you are going to your office, the tomato prices will be around 30 rupees per kg or 50 rupees per kg, but once you will be coming back, you can buy it for 2 rupees kg also, and sometimes they will tell that okay, take it. Why? There is no storage, or storage is there but they cannot afford. Is it there or not? So what we have done is, we have utilized a simple oldest traditional method I would say, the evaporative cooling technology. Evaporative cooling technology we have utilized, and now what we have done is, we have made a mobility vehicle with that principle, which can store or which can retain the temperature of 16 to 18 degrees centigrade, and it is vehicle, it is completely mobile vehicle is there. So those things are there, means the technology still exists in the domain, but we have to see that how we are going to transform that particular science or engineering or application in our particular area. So that is the foremost thing which you have to do. Now these are all things which you can just go to our website and you can see. Next is, we have 16 faculties with us. 16 faculties, all are well qualified. For the opportunities, BTech students, we take BTech students from JOSA, JEE exam, okay. There is another thing, that is MTech we used to take. MTechs are of two type. One we take from GATE and one we take from self-financed thing. Sometimes we fill our all seats, 15 seats with GATE, sometimes we don't. So there is always the opportunities there. Say those who are having, those who are not having GATE, they also can apply. There will be a very simple thing, that you will be coming here, you won't have to there is no application and everything. The application will be called later on, and then you will be having interview and you will be selected. So there is an opportunity to work in this particular department. PhDs, we have 2 times advertisement for the PhD, full-time PhD, institute PhD it is called, with institute scholarship. We have 2 times we are doing that thing. Apart from that, each and every faculty has projects. So projects, we are hiring JRF. In that the requirement is NET or GATE. So that is the only restriction we have, but in that there is huge opportunities there, because in our department currently I think more than 20-25 projects are running, and in that we have taken 25 students also. So that is the opportunity you can always grab. Again, now these are the things which you can come here and you can do. But say for example you are working in some other institute and you want to do your research or say one objective from here, that is also possible. We have this provision that if say not only we will be just analyzing your sample, but you can just take the permission from your host institute. You can come here, you can perform your experiments on the cold plasma and you can go back. No financial implication on us. You have to take care of those things. Again, if you have some samples, you can send that samples to us. We can just do the sample analysis and we will send it back to you. We have in NIT Rourkela, we have CRF, Central Research Facility. In that we charge very minimal amount, and that amount can be utilized for each and every high-end equipments whatever we have. We have NMR, we have HPLC, high-grade HPLCs, and MSMS we have. So these all equipments are there, that is AAS, everything is there, that is related to our domain. So we have all those facilities with us, which you can utilize. SEM, TEM, everything is there, but you have to go on our CRF website. You can just do the registration and pay the money, and you can get the slots and everything. So that is also there. So with all these things, I guess that your association with us should not only be till here. Why? Because whenever I am organizing any Karyashala, whenever I am organizing any workshop, by, say for example, by God's grace or by anything, few students are coming to our institute. So that is the what you can say reach or the awareness which has been created by these particular things. This should not be taken only as coming here, studying and going back, but you can always be in touch with us. We are always there for you. Those who wants to pursue career onwards, we have a special cell also. Counseling center is also here. If you don't want to talk to us, you can talk to them. That they are also based, and they are open for everybody. So those things are also there in NIT Rourkela. So that is a very good opportunity which has been given by this particular institute. So I assume that there will be somebody from you that who will be joining us soon, and if anything, do definitely let us know that what is the problem you are facing. We are there to help you guys. Now we have shared a Google form on your WhatsApp things. Now can you just open that thing, and each and everyone, I request that you have to give a feedback for this particular course, and this feedback will be definitely be utilized for improving further, and it will be giving us a new domain that what is your demand in this particular area, so that we can cater into that thing. And we have to send these reports and everything, so kindly be concise. If there is writing things are there, so kindly write in concise manner that what you want, and everybody just fill the form and let us know that what is your things. And meanwhile, I will be just talking to some of you that regarding that, what extra you wanted from this course which we missed, and we might have added into that thing. Give it to him. Do you feel anything that was actually required, and we could have done that thing?
No sir, as far as I know, everything is covered, and as much as I know, I am BTech student, I don't know much more about masters and PhD.
Okay, thank you.
Oh, sir, according to me, it's good, sir.
Okay, thank you. Give it. Did you got the hands-on experience on the practicals?
Yes, sir.
That digestion and everything you understood?
Yes, sir.
So now, say for example, if I am asking you, what 3 chemicals we have used for digestion of that, crab shell and
HCl, NOH, and acetic acid, sir.
Okay. So what was it? Did we have raised the temperature of that? We have raised the temperature to in the incubator. We kept that, or digestion was there? Incubated. We incubated. Why we incubated that? Anybody? Subit, you tell.
So incubation is done, for example, in chitin to chitosan conversion, higher temperature is required. So for that we have incubate.
Okay, understood. So those things, that is crab shell, these things, fish scales and everything, we bought it from the market only, and now we are very much interested to work on this particular topic. You won't believe that now we have recently purchased many of the things just to start the thing. So if somebody is from master's first year or not in second year of PhD, I think this is a very good topic to work on. Like just conversion and everything. Nobody actually I didn't find any paper, but you might find some papers. But I didn't find that how it is dissolving in that particular things. And if you will see in the foreign countries now, what they are doing is they are making the water purifiers from this particular shells only. They are just arranging the cells, they are just putting the water into that thing, that water is getting purified. That is also happening. So that is also an innovation thing. The BTech students or the MTech students can take this kind of project and they can just not publish. You can even apply for the IP also. Okay. Anybody else? Give it.
Good morning, sir. Thank you for giving the opportunity for 10 days GIAN course. Your innovative approaches for sustainably blue circular bioeconomy of food and feed value chain. Understood. More knowledge about the seafood processing and practical.
Was the practical and the theory was well balanced? Like you were getting the link between that as he was teaching and you were going for the experiments, it was connected or not?
Connected, sir.
Okay.
Understood.
Okay.
Thank you, sir.
Good morning, sir. It was really good. I got to know more about sustainability and many valuable insights on sustainability. And one more thing is this helped me to how to approach my research in my field. That's it, sir.
Good morning, sir. So first of all, thank you for giving me this opportunity. So since I'm from BE Agricultural Engineering, so I get to know more about so how the things work in food process engineering, and moreover, the Brijesh Tiwari, sir, those past 9 days, his lecture is very good, and nowadays we tend to focus on sustainability, which is very important in agriculture as well as in food. So moreover, I think I need to thank Ganga sir who shared this message with us. So I get this opportunity to attend this, and my experience in NIT Rourkela is very awesome, and overall experience is nice, sir. Thank you.
Okay. So as he was mentioning about agriculture engineering, we are also from agriculture engineering background. So not to say anything about don't take it otherwise. I am also from agriculture engineering background. When I entered into my masters in Kharagpur, we were having very less knowledge about this food processing, because in our institutes we were more focused. I have done all my trainings in Budhni, in tractor and everything. So this is entirely a new area for me when I entered into my masters. But agriculture engineering is such a domain that there are 5 to 6 degrees you can get it from there only. There is soil water is there, there is farm machinery is there, microbiology is there, everything is there in that. So that is why if a person is from agriculture engineering, he should also know, don't think that it will be difficult, but you can manage. But you will not be having the knowledge as that of the core food technology or the food engineering background BTechs, but at least we will be having some courses that are only utilized. But for that only, these kind of courses are very good. Try to learn as much as from the workshops, from the online lectures, from the NPTEL. So those things only will be giving you a new insights on those things. Okay. Anybody else?
Sir, this is Naveen. Currently I am pursuing a PhD, sir, in SRM University. In SRM University we have several instruments, but comparatively here there are more high-end equipments. So as you mentioned earlier, we can able to collaborate. There I can't do, I can do it here by using.
You have to just write us a mail.
Okay.
Whenever there will be slot will be there. Say for example you want to work on cold plasma, you have to mail me. I will tell you that when I have the slots, I will call you at that time. You can come with your sample, you can perform your experiments and you can leave. So there is no such kind of thing is there that there is foundation and everything. We are open, like for Tejpur University, for IIT Kharagpur, we are just no open. We always let them come in and do the experiments and they go back from there.
So that will be very helpful for us.
Yeah, definitely. Whatever you want, you can just write to us. It is better that it will be collaborative. Then you will also get insight. We will also get insight that what is happening in your institute.
Sir, good morning, sir. Sir, currently I am pursuing MTech in SRM University. So I am just working in protein isolation and alternative proteins. So sir has taught, Brijesh K Tiwari has taught about protein isolation, which has helped me in a lot. And I have asked some personal doubts to him, which he improved in many things. And I would like to thank NIT Rourkela for giving me this opportunity. And I like to thank all PhD scholars who are helping accommodation and food. Thank you, and looking forward for more training programs in NIT Rourkela.
Yeah, sure. So we will be soon be organizing this conferences and everything also. So you can come in that. Now we have one more, like if you your friends wants to come again, we have again one GIAN course in January. We have again one GIAN course in July and then in December from our department only. So that is the opportunity. You should always give, like if you came, try to pass it on to your friends so that they can also come and see the facilities here. And sometimes we will also come to your institutes and we will also see that how we are going to collaborate in the future things. Okay. Who will tell? You want to tell?
Sir, I had a doubt, sir, that we had in UGC net there is a classification like for PhD in cracking UGC net, PhD, JRF and AP, sir. If I come to under the project scheme, what I want to crack?
Only you have to have net. JRF, if you will be having, that is added advantage. If you are having net for project, that is more than sufficient. But if you are having JRF, you can apply in our regular calls also. Regular calls, you can just write that, what is the term? Admission, external fellowship. Admission with external fellowship. And that you will be, like there is no, in like here in NIT Rourkela, what we have is 2 scholars per institute scholars we have, unlimited external and unlimited project scholars. So we can take that. So if you are having JRF, then that is done. You can just apply and we can just take you.
Okay. Thank you.
Yeah.
Thank you so much, sir, for organizing this GIAN course on blue circular economy. Behind that, I have idea about the microalgae culture, but after joining that, I have gained lots of, just like the plasma technology. I don't know what is the plasma technology, but I know that. I only say my senior results like DSC graph, FTIR and NMR graph, but I just looked at how that analyze particular graph and how we can sample analysis with the DSC and everything. Thank you so much and organizing that.
Okay, that what she told is that is the thing that we have seen in papers. We will see that DSC graphs are there, FTIR graphs are there. How to analyze that? So that is the major problem, because writing is not a big deal. Writing is not a big deal, but just to know that when this OH, when is this COOH, what is that actually these graphs are telling. If you will get to know about that things, you can write paper very fluently. Only is the need that what that particular technology depicts. If you will be knowing that is done. DSC, what it depicts, if you will be knowing, you can write a whole paragraph on that particular thing. FTIR, what it depicts, you can do that thing. So that is most important thing in any of the technology, that how you are going to analyze that particular thing. We can develop, say for example, MS and everything, but how to analyze that things. So that is more important. And there will be one session in analytics will be there. Very soon it is going to happen. Only analysis we will be talking in that. Means no, it was there last year also. Means DSC, how you are going to write the results of that thing. So that is what we are doing actually. So you can also join online also and offline also. We are having both the things in that. So you can just say if you want to interpret the result of FTIR, so that you can just learn from there completely, like 2-3 things we used to take, not only one, different food materials we used to take. We used to analyze and we will give you the result how to write those things. Okay, that is also there. So I think most of you have already filled the forms. So I think we can, with this, we can close the session, and I wish you all the best. Do not hesitate never to contact us. And for me, I am very much fortunate to have my scholars, so they will be always like, if you will be messaging me, I will be definitely getting the message from them. So that in that way, do not think that I will not be getting the message. I will be definitely getting the messages. Whatever you want, I will try to give you those things. So with that, I wish you all the best, and I hope that these sessions will be giving you the opportunity to come here also and go wherever you want and flourish in your future. Thank you so much. And with this, I close this session and GIAN course. Thank you so much.